All right, here we go. So 2B.2 compositions of functions. We're going to start part A, which are going to be examples 1 through 6. It should fold and make a little booklet that goes nicely in your handy dandy notebook. Thanks. Whatever the next pages are. I have to write that out for you. Bless you. All right, so we've created new functions using algebraic operations in the previous course. Yes? Yeah. Create AP Algebra 2. How do I know we did that? Because I taught the class and we're currently doing it right now in AP Algebra 2. Okay? Uriel. All right, so the process of combining functions so that the output of one function becomes the input of another function is called composition of functions, okay? When you have composition of functions, it looks like it's this. It looks like the word fog, but it is f is composed of g of x, right? That means I'm taking whatever g of x equals and I'm plugging it in to f for x, right? Substitution on substitution, okay? So when we look at here, we're going to go to g of x first to get our first output. And then we're going to take that output and it's going to become the input of our f of x, right? And that's all composition is, a function in a function, okay? This has to happen first for this to happen next, okay? That is essentially what we're talking about, okay? It's important to understand the notation. So when you see function notation, there are two ways that you generally are going to be seeing it with f and g of x. So here, understanding that f composed of g of x equals f with g of x plugged in. But if I go the other way around, g composed of f of x. So if we end up with g composed of f, that means I'm now taking f of x and I'm plugging it into g. Majority of the time, those are two different equations, okay? Does anyone remember what it means if they are the same equation? What does it mean if they're the same equation? I know this. Y'all know this. I feel it. They do. If they equal each other, if f of g of x equals g of f of x, it means there's a relationship between the two functions. Inverses. They are inverses of each other. Okay. Yeah, it was in there somewhere, right? Okay. All right. So here we go. So just to show you that it is not a commutative property, we're going to model it using the following two functions. So we have f of x equals 3x minus 5, and we have g of x equals 4 minus x. So first we're going to do a little bit of fog. I call it fog because when I was a kid, and like most people, it looks like fog when you write it in that form. So f composed of g of x means that I'm taking whatever, not that. F of x composed of g of x. That means whatever g of x is, I'm plugging into f of x, right? So what is g of x? G of x is 4 minus x. So that means I'm going to substitute with 4 minus x. Please tell me that this is ringing a little bit of a bell. Okay, so everywhere in f of x, we're going to put in 4 minus x. So this equals 3 parentheses, and we have 4 minus x minus 5. Okay. The key thing is with compositions, you want to make sure that you completely simplify. That means remove unnecessary parentheses and combine like terms. So in order to do that, we're going to do what? Distribute. So our final new function is going to be 12 minus 3x minus 5, which equal 12. What I write? Oh, I said 12. I said 12, and I have no clue why or how. I said it. I don't know. Where did that come from? She doesn't know. She has no clue. 7 minus 3x is what our f of g of x is. Look here, guys. I can't either. I don't even know how those are even tied together. You know what? I don't know. I don't know. Huh? Yeah, just keep going. All right, here we go. So we did f composed of g of x. Now at your table, quickly do g composed of f of x. So you're going to do g composed of f of x.
Actually, no, actually, I don't think we should make it right. No.
No, I get what you did on the first one.
Which part?
No, I can't put everything in that. Oh, wait, no, I get it.
No, it's not.
Sorry.
It's 4 minus, and then in parentheses, 3x minus 5. So it's 4 minus 3x plus 5.
You got to distribute the negative.
Yeah, so 4 minus 3x plus 5.
There we go.
And then
She's been doing this the whole
add
time.
the 4 and 5, and then I like turns, and you get 9. And then minus.
Okay, we did it.
Yeah.
All right. All right. What's the composition of g composed of f of x? What do we get?
9 minus 3x.
9 minus 3x. Okay. So notice here, were they the same? No. And because they're not the same, we know in the end that they are not inverses of each other, which isn't what this is about, but it's our prior knowledge that I felt like I should throw at you. Okay. So we're